Hello, I'm Sanath Surawar, and I'm going to be presenting my final year project entitled Multimodal Review Helpfulness Prediction. My supervisor for this project was Professor Luan Tuan, who I thank for his contributions and help during the project. To introduce, why is review helpfulness prediction important? Online reviews have become an essential part of the decision-making process for customers. For example, the global e-commerce market size was valued at USD 9.09 trillion in 2019, and it is expected to grow at a compound annual growth rate of 14.7% annually. And hence, this is a growing industry, the growing consumer base, which makes the relevance of reviews much more important. 93% consumers say that online reviews have an impact on their purchasing decisions, which makes it ever so more important to have helpful reviews on the top that consumers can make better decisions on whether to buy something or not. Consumers are also willing to spend 31% more for a business with good reviews. As such, this topic is extremely relevant and important. The purpose statement, thus, is to explore the effectiveness of using multimodal data, including text and images, to predict the helpfulness of online product reviews, to provide a more comprehensive understanding of the factors that contribute to its helpfulness. For the project stages, initially, literature review was done, after which existing methods were explored, after which improved multimodal algorithms were seen, and results are analyzed. For the sake of the video, I'll be focusing on the methodology. In terms of the existing text-based algorithms, these three are the ones that are particularly helpful for review helpfulness prediction. The first one being BiMPM, or bilateral multi-perspective matching, which is a neural network architecture that is designed to model the semantic similarity between two texts, such as review and product description. ConvKNRM, or convolutional kernel-based neural ranking model, is a deep learning architecture designed to rank documents for information retrieval and recommendation systems. The model is based on the concept of soft matching, which enables it to capture the semantic relationship between query and document in a more better way than traditional information retrieval models. PRHNet, or Product-Aware Review Helpfulness Prediction, is a deep learning model designed for predicting the helpfulness using a hierarchical structure, which involves an attention mechanism to focus on important features and words in the review, and the associated metadata in the product, such as product category or product brand. In terms of the improved multimodal algorithms, there's MCR, which is multi-perspective coherent reasoning. The model is designed to capture the relationship between textual and visual information in reviews, and to leverage these to predict review helpfulness. For example, a review has review text and review image, well, a product also has product text and product image. The cross-model and intra-model relationships between these can be used to generate or predict review helpfulness at a better rate. Selective attention and natural contrastive learning are two techniques used in Sankel. Selective attention refers to the ability to focus on certain features while ignoring others. In the context of review helpfulness prediction, selective attention can be used to determine which parts of the review, example text and/or images, are most relevant for predicting its helpfulness. Natural contrastive learning is a technique used to improve the representation of input in the model. It works by contrasting similar inputs against each other to create a more informative representation. There are two inherent drawbacks to multi-perspective coherent reasoning, which are ad hoc representations and hard alignment issues, which are overcome in the adaptive contrastive learning model by implementing an adaptive cross-model contrastive learning to better understand the modalities and overcoming hard alignment with a multimodal interaction model. Take a case study of how a multimodal algorithm would work. We've taken the product Teflon pan used here, and there are three reviews which have three different helpfulness scores generated on running the MCR framework. To analyze why they've gotten these scores is straightforward. The first one has limited review text, but relevant images, and as such, has a helpfulness score of 2. The second one has detailed review text, and more importantly, has the review image matching the description of the review and the product, making it really helpful. The third one, the review text outlines that the pan has scratched, as mentioned here. However, since the review image isn't able to back this up, the entire review is deemed to be irrelevant and thus has a helpfulness score of 0. Moving on to the result analysis. The dataset used was obtained from two popular e-commerce platforms, Amazon and Lazada, in 3 categories: clothing, home, and electronics. The evaluation metrics that we used were first, MAP, which is mean average precision, which is a measure of the quality of a ranking algorithm. It takes into account not just the relevance of each recommended item, in this case, whether a review is helpful or not, but also the order in which they ranked. Second one is NDCG, or normalized discounted cumulative gain, which is another commonly used metric for evaluating recommendation algorithms. It takes into account the relevance of each recommended item, as well as its position in the ranking, with a logarithmic discount for items that are ranked lower. To analyze the results, first, comparing text-based with the multimodal, I noted that the multimodal algorithms generally perform better than the text-based counterparts on both datasets for all three product categories. For example, in the Lazada dataset for clothing, the best performing text-based algorithm by MPM has a mean error persistence score of 62.1, while the best performing multimodal algorithm, ACL, has a MAP score of 70.3, showing an improvement of over 13%. Other points to be noted were that, as we can see, multimodal algorithms perform better than their text-based counterparts. The performance of algorithms was relatively consistent across different product categories, with a few exceptions. And the algorithms also perform better on the Lazada dataset compared to the Amazon dataset. In conclusion, the superior performance of multimodal algorithms is evident, proving that the incorporation of diverse modalities, which could be text, image, videos, audio, can significantly enhance the efficiency and accuracy of review helpfulness prediction. In terms of implication, this research opens the door for many review helpfulness tools that can help e-commerce platforms classify helpful reviews for better use by the customers and consumers, and help increase sales for the business. Thank you.